Hello students, today we are going to start with the chapter Ionic Equilibria. Now we have studied in 11th standard about chemical equilibrium. So that principle is applicable in this chapter. Now what is chemical equilibrium? It is a state in which concentration of reactants and products do not change with time. So, what do you mean by ionic equilibrium? Ionic equilibrium is defined as the state of equilibrium between what? Between ions and unionized molecules. What I said? It is the state of equilibrium between ions and unionized molecules. So, in this chapter, basically we are going to study about the ionic equilibrium. It may be equilibrium between H plus OH minus ions and water molecule, or it may be equilibrium between weak acid, weak base. So all these parts we have to cover in this chapter. Okay. Now we'll start with the chapter. So first point in this chapter, that is types of electrolytes. Now what we have to remember, what are electrolytes and non-electrolytes? Electrolytes are compounds which ionize into their aqueous solution, and on the other hand, non-electrolytes do not ionize in their aqueous solution. So electrolytes will give you ions and non-electrolytes will not give you ions. Now the point is type of electrolytes based on their extent of ionization, means to how much extent they can ionize. There are two types of electrolytes. First type is strong electrolyte, and the second type is weak electrolyte. What is the difference between the two? In case of strong electrolyte, these electrolytes dissociates completely into their aqueous solution to give ions. And in case of weak electrolyte, there is partial dissociation. What I said, for strong electrolyte, complete dissociation, and for weak electrolyte, partial dissociation. We can take example for strong electrolyte as NaCl. NaCl in its aqueous solution will give you Na plus and Cl minus ions. And for weak electrolyte, we can take example of CH3COOH, that is acetic acid. It is a weak electrolyte, therefore partial dissociation of this takes place into CH3COO minus, that is acetate ions, plus H plus. NaCl, complete dissociation, strong electrolyte. Acetic acid, partial dissociation. Partial dissociation means what? Some molecules of acetic acid gets converted into corresponding ions and some part remains as molecules. So this is the difference between strong and weak electrolyte. So this much is clear to you. Ionic equilibrium means what? It is the equilibrium between ions and unionized molecules. Then types of electrolytes, strong electrolytes and weak electrolytes, partial dissociation for weak electrolyte and complete dissociation for strong electrolyte. Now the next point in this is degree of dissociation. Degree of dissociation is defined as the fraction of total number of moles of an electrolyte that dissociate into their corresponding ions. It is denoted by symbol alpha. What is the definition for degree of dissociation? Fraction of total number of moles of an electrolyte. So formula will be total number of moles of an electrolyte that are dissociated divided by total number of moles of an electrolyte. Number of moles of an electrolyte that undergo dissociation divided by total number of moles of an electrolyte. So it is called as alpha, that is degree of dissociation. Next is when we have to calculate percent dissociation. The formula for this will be alpha into 100. Okay, so this is the degree of dissociation. Alpha, number of moles of an electrolyte that are dissociated divided by total number of moles of an electrolyte, and percent dissociation is equal to alpha into 100. So numericals can be asked based on this formula. Next point in this is acids and bases. Now in our day-to-day life, we came across various types of acids and bases like citric acid, which is present in lemon, then tartaric acid present in tamarind paste, ammonia, which is used as a household cleaning agent. So these are some of the acids and bases which we came across in day-to-day life. Now, there are various concepts or various theories put forward by scientists to explain this concept of acids and bases. Each theory is based on different concept. So in this, the first theory which was proposed is Arrhenius theory. Now according to Arrhenius theory, what is an acid? Acid is a substance. Acid is a substance which contains hydrogen. which will give H plus ion in aqueous solution. We are looking for Arrhenius theory of acids and bases. According to this theory, acid is a substance which contains hydrogen and which gives H plus ion in aqueous solution. And according to this theory, base is what? Base is a substance which contains hydroxyl, that is OH group, and in aqueous solution it will give OH minus ion. So understood the concept of Arrhenius theory. Acid contains hydrogen and will give H plus ion in aqueous solution, and base contains hydroxyl group, that is OH group, and will give OH minus ion in aqueous solution. So now we will see example for this. So for acid we can take example of HCl. HCl in its aqueous solution will give you H plus and Cl minus ion. So this acid contains hydrogen and it will give H plus ions. An example for base will be NaOH. So NaOH in its aqueous solution will give Na plus and OH minus ions. So this is the Arrhenius theory. Now there is one exception for this Arrhenius theory. What is the exception for that? That is, this theory could not explain the basicity of substances like ammonia. Ammonia contains hydrogen, but the nature of ammonia is basic. Ammonia behaves as base. So what is the reason behind this is not explained in this Arrhenius theory. So this is the exception or limitation of this Arrhenius theory. So this is the first theory. Now the next theory is Bronsted-Lowry concept. Now this Bronsted-Lowry concept or Bronsted-Lowry theory is based on proton transfer. Based on proton transfer. So according to Bronsted-Lowry concept, acid is what? Acid is a substance which will donate proton. And according to this theory, base is a substance which accepts proton. Understood the difference? Acid is proton donor and base is what? Proton acceptor. On this proton donor and proton acceptance capacity, there is a conjugate acid base pair. So the example for this is see HCl plus NH3, hydrogen chloride plus ammonia. In this there will be formation of NH4 plus and Cl minus. HCl plus NH3 In aqueous solution, there will be formation of Cl minus aqueous and NH4 plus. So what is happening here? HCl is giving proton to NH3. So in this case, HCl is what? It is proton donor. So it is denoted as acid 1, and corresponding base will be Cl minus, because when the reaction takes place in this, Cl minus will accept proton. So this is what? Base 1. HCl proton donor acid 1, and Cl minus will accept proton, which will be base 1. Similarly, NH3 is accepting proton. So it is what? Proton acceptance means base 2, and NH4 plus will donate proton. So it will be acid 2. So acid 1 and base 1. This is conjugate acid base pair. Similarly, this base 2 and acid 2. It is also conjugate acid base pair. So in exam, question can be asked, reaction will be given and you have to write down conjugate acid base pair. So proton donor and proton acceptor are what? Conjugate acids and bases. Here HCl is acid, Cl minus is base, ammonia is base, and NH4 plus is acid. So this is the Bronsted-Lowry concept of acids and bases. Now the more generalized theory of acids and bases is put forward by G. N. Lewis, which is based on electron transfer. Electron pair is considered in this theory, and according to this theory, acid is anything which accepts a share of electron pair. Share of electron pair acceptor. And base is share of electron pair donor. So, what is said in Bronsted-Lowry theory? Hydrogen is proton donor. And according to Lewis theory, acid is what? Electron pair acceptor. Similarly, according to Bronsted-Lowry concept, base is what? Base is proton acceptor, and according to Lewis theory, base is electron pair donor. Now this electron pair is not completely donated to other substance. It is shared. There is a sharing of that electron pair, and there is formation of coordinate bond. See example, BF3, boron trifluoride and NH3. In case of ammonia, there is presence of lone pair of electron on nitrogen. This electron pair is shared between this nitrogen and boron. So there will be formation of BF3 and NH3, and due to this sharing there is formation of coordinate bond. So in this case ammonia is donating electron pair, so ammonia act as base, and BF3 is accepting electron pair, so it acts as acid. So the limitation of Arrhenius theory, which said that theory does not explain the basic nature or the acidic nature of these compounds like ammonia and BF3. It is explained in this Lewis theory. So these are the three theories which gives various concepts about acids and bases. So let us revise. According to Arrhenius theory, acid is what? Acid contains hydrogen and will form H plus ions in aqueous solution, and base contains OH group and will form OH minus ions. According to Bronsted-Lowry theory, acid is what? Proton donor and base is proton acceptor. And according to Lewis theory, acid is what? It is electron pair acceptor and base is what? Electron pair donor. Okay. Thank you.